We used to have this biological safety net. You know the one I'm talking about.
Mm-hmm.
You're watching a movie or maybe looking at a tech demo of a robot, and even if the graphics are, I don't know, 99% perfect, that last 1% sets off an alarm in your brain.
The uncanny valley.
The uncanny valley, exactly. It was our evolutionary radar just screaming, "This isn't human, keep your distance."
Yeah.
But today, we're diving into a source that suggests that radar isn't just jammed, it's low. It's obsolete. We haven't just crossed the valley, we've climbed out the other side.
And what's waiting for us there is something else.
Something else. The synthetic faces waiting for us there, they don't just look human. According to the data we have today, they look more trustworthy than actual human beings.
It's a terrifying premise, isn't it?
Yeah.
I mean, we are essentially discussing the moment where our own visual perception stops being a reliable tool for navigating reality.
Yeah. And for everyone listening who uses these dives to build out their annotated bibliographies, and I know many of you are tracking synthetic media, this is a foundational text. You're going to want to get the citation details down.
Oh, absolutely.
The paper is titled, "AI-Synthesized Faces Are Indistinguishable from Real Faces and More Trustworthy."
A title that really doesn't bury the lead.
Not at all. It was published in the Proceedings of the National Academy of Sciences, or PNAS, on February 14th, 2022.
Mm-hmm.
The authors are Sophie J. Nightingale from the Department of Psychology at Lancaster University and Hani Farid from UC Berkeley's Department of Electrical Engineering and Computer Sciences.
And that collaboration is worth noting right off the bat. Psychology and engineering.
Right.
Because usually when we read papers on generative adversarial networks or GANs, they are pure computer science.
Yeah.
You know,
Oh.
all about pixel density and training times.
Yeah.
This paper is different. It's a perceptual study. They built the tech, but the research is all about what that tech does to the human brain.
And that's our mission for this deep dive. We are going to unpack the 3 specific experiments they ran. First, indistinguishability. Can you even spot the fake?
Right.
Then we're going to look at learnability. Can you train yourself to spot the fake? And then the most psychologically complex finding, the trust paradox.
And that creates a set of implications that I think will define the next decade of how we interact with each other online.
So before we get to the human subjects, we have to understand the generator. The paper focuses on GANs, specifically a system called Stylogene 2. How should we conceptualize this engine for our notes?
I think the most helpful analogy is to take the acronym seriously. Generative adversarial networks. It's built on conflict.
Okay.
Imagine 2 AI entities locked in a room. You have a generator and you have a discriminator.
So a forger and a detective.
Perfect.
Yeah.
The forger starts with nothing, just random noise. Digital static. Its goal is to arrange those pixels into a face.
But it doesn't know what a face looks like at first.
Not at all. It's just guessing. It slides its first attempt across the table to the discriminator.
And the discriminator is the one holding the answer key.
Exactly. The discriminator has access to this massive data set of real human photos. So it looks at the forger's attempt, compares it to the real thing, and says, no, that's fake.
Okay.
But, and this is the crucial part, it provides feedback. It essentially says, you failed because the distance between the eyes is wrong, or the skin texture is too smooth.
So the forger just tries again and again, millions of times.
It's this high-speed automated loop of critique and improvement. The forger gets better at lying. The detective gets better at spotting the lie. They push each other toward this mathematical perfection.
Until
Eventually the forger creates an image so convincing that the detective, which has access to all the real data, can't distinguish it from a real photo anymore.
And that's style GN too. But the authors make a really important point that this isn't just about capability, it's about accessibility. They use the term democratization.
Which is usually such a positive word, right?
Right.
But here it means the barrier to entry has just collapsed.
Yeah.
You don't need a Hollywood budget or a render farm anymore.
Right.
The code for StyleGAN 2 is out there.
Right.
A moderately skilled person can synthesize speech, swap identities, or generate these hyper-realistic faces on a decent laptop. We have democratized the ability to manufacture reality.
Which brings us to the first big question the authors posed in Experiment 1. If the machine detective can't tell the difference, can a human?
Let's look at the method. They recruited 315 participants. The setup was pretty standard, a binary classification task.
Yep.
They showed them 128 faces. Half were real photos, half were synthesized by StyleGAN 2. The participants just had to answer one question, real or synthetic.
Okay, let's establish a baseline. If I know absolutely nothing, if I am just guessing at random, I should get 50% accuracy. That's chance.
Correct. 50-50.
So how did the 315 humans do?
They averaged an accuracy rate of 48.2%.
48.2. So
Yeah.
humans performed worse than a coin flip.
That's what the data says. And it implies we aren't just guessing. If we were guessing, we'd be at 50.
Right.
Being below 50 suggests we're being actively deceived. The visual cues we rely on to identify humanity are being used against us. We're consistently misclassifying the fakes as real.
But the data wasn't the same for all faces, was it? This is where the paper really gets into algorithmic bias. There was a specific interaction they found.
Yeah, between gender and race. This is a critical finding for anyone studying ethical AI. They found that white faces were the least accurately classified.
So people were fooled by the synthetic white faces more often.
Significantly more often than faces of other racial groups.
Why is that? Is the AI just, I don't know, better at drawing white people?
In a sense, yes. But it's not magic, it's just the data. The authors trace this back to the training set. Trustworthy 2 was trained on a dataset called Flick Our Faces HQ.
Okay.
And if that dataset is predominantly white, which it is, the generator has simply had more practice, more iterations on white features.
It's a frequency bias.
It's bias in, bias out. The model captures the lighting, the skin translucency, the hair texture of white faces with a much higher fidelity because it's seen thousands more examples of them.
Which has this massive downstream implication for disinformation, which I want to get to. It means if you want to create a fake persona that no one will catch.
You're incentivized to make them white. It creates this technical pressure toward visual homogeneity in fake profiles.
Yeah. Okay, so experiment 1 establishes that basically untrained humans are helpless. We're worse than chance. But, I like to think I can learn. If you taught me what to look for, the weird backgrounds, the mismatched earrings, I should get better.
That is the optimistic hypothesis, and it's exactly what they tested in experiment 2. They brought in a whole new group of 219 participants.
And the protocol was different this time.
Right. Before the experiment started, these people went through a training tutorial. They were shown examples of common Jan artifacts.
Like what?
They were taught to look at the background, to check for asymmetry in eyeglasses, to really look at the teeth, the typical tells.
So they were given the answer key to the glitches.
And this is crucial. They got trial-by-trial feedback. After every single guess, the system told them correct or incorrect.
So in any normal learning environment, you'd expect a curve. You'd expect accuracy to go up as they figure out the game.
You would expect that. But the accuracy only rose to 59.0%.
59. I mean, okay, it's better than 48, but you're still failing the test, practically speaking.
And here is the damning part. They compared accuracy in the first half of the session to the second half.
And
there was no improvement over time. Even with immediate feedback, people did not get better at spotting the fakes as they went along.
that feels so counterintuitive. We're pattern matching machines. Why couldn't they learn?
Well, the authors argue that we've basically hit a saturation point in visual realism. The reason people didn't improve is likely because, for many of these synthetic faces, there are no artifacts to find.
The tells just don't exist anymore.
They're gone. You can't learn to spot a glitch that isn't there.
So the whole idea of media literacy, at least in the sense of just look closer, it's effectively dead.
Visually, yeah. We can no longer just rely on our eyes to verify what's real.
Which forces us to rely on our gut, our instinct. And that leads us to the third experiment, which I have to say was the most unnerving part of the entire paper.
Experiment 3, the trust factor. This pivots from identification to perception. If we can't tell them apart technically, how do we react to them emotionally?
So the setup, 223 participants. They aren't asked, is this real anymore? They're asked to rate the face on a scale of 1 to 7.
1 being very untrustworthy, 7 being very trustworthy.
Right. Now, logic would say that if the faces are indistinguishable, the trust rating should be about the same.
Or maybe, if there's any uncanny valley feeling left over, the AI should be rated lower.
But the data just flipped the script.
It absolutely did. The average rating for real faces was 4.48. The average for synthetic faces was 4.82.
So the synthetic faces were rated as statistically more trustworthy than actual human beings.
And if you look at the extremes, it's even more stark. The top 3 most trustworthy faces in the entire study, all synthetic. The bottom 4 least trustworthy, all real people.
This is the part that needs a deep, deep explanation. Why? How can a mathematical approximation of a face trigger a stronger trust signal in our brains than a real person?
The authors lean on a concept from evolutionary psychology called the averageness hypothesis.
Okay, and usually when we say someone looks average, that's not exactly a compliment, but it means something different here.
It does. In this context, average means mathematically typical. It means features that are close to the mean of the population.
Okay.
Evolutionarily, we are hardwired to prefer average faces. Why?
Mm.
Because deviations from the average, extreme asymmetry, unusual proportions, could historically signal genetic mutation or illness or poor health.
So average signals fit and safe.
Exactly. So our brains like average. That connect that to the Jan.
How does the Jan learn?
It processes thousands of faces and tries to find the patterns that fool the discriminator. In doing so, it tends to regress toward the mean. It smooths out the quirks. It creates faces that are mathematically symmetrical and proportional.
Whereas real humans have baggage. We have asymmetrical smiles, one eye is slightly lower than the other. We have skin blemishes, tired bags under our eyes.
Exactly. Real faces have noise. The AI filters out that noise. It presents us with a face that is hyper-average and therefore triggers our biological trust instinct more strongly than reality itself.
It's hacking our evolution. It's a super stimulus for trustworthiness.
That's a great way to put it.
So we have a technology that is indistinguishable from reality, that's unlearnable, and that's intrinsically more trustworthy. The so what here feels massive.
It is. The authors categorize the dangers into a few buckets. The first one is non-consensual, intimate imagery.
Often called revenge porn.
Right, but the authors point out that revenge is a misnomer. That implies a motivation or a prior relationship. With this tech, you don't need a relationship. It's simply the abuse of using someone's likeness in explicit material without their consent.
And because it's democratized, the victim doesn't have to be a celebrity. It can be anyone.
Anyone. The second threat is fraud. Think about those trust ratings we just talked about. If I'm a scammer setting up a fake profile on LinkedIn or a dating app, I don't just want a photo that looks real. I want a photo that you instinctively trust.
So you use the AI to generate a face that statistically bypasses my skepticism.
It's a social engineering weapon. You're hacking my first impression before you've even sent a single message.
And the third threat is disinformation. The paper describes this as adding jet fuel to misinformation campaigns.
Yeah, we're used to bots having, egg avatars or stolen photos you can catch with a reverse image search.
Right.
Now, you can generate an army of unique, non-existent, trustworthy-looking citizens to push a political narrative. And if you remember the racial bias,
you're incentivized to make them white, which completely distorts the perceived demographics of online discourse.
Exactly. And there's a fourth implication the authors discuss that I think is the most intellectually slippery. They call it the liar's dividend.
Okay. What's that?
It's a fascinating second-order effect. We usually worry about the fake passing as real. The liar's dividend is the opposite. It's the ability to claim that the real is fake.
So a politician gets caught on tape saying something illegal.
In the past, that recording was proof.
Yeah.
Now, they can just say, that's a deep fake. You know what AI can do. Don't believe your own ears.
Even if the recording is 100% authentic.
Exactly. The mere existence of high-quality synthesis casts this shadow of doubt over all authentic media. It pays a dividend to the liar. It lets them escape accountability just by leveraging the confusion.
It erodes the shared baseline of reality. If everything can be fake, nothing has to be true. So did Nightingale and Farid offer any solutions, or is this just a documentation of our demise?
No, they do offer solutions, but they're systemic. They emphasize that individual vigilance, just look closer, is a dead end.
Right.
The solution has to be technical and regulatory. They call for robust watermarking.
Like a digital fingerprint embedded in the file itself.
Yes, something woven into the synthesis process that's invisible to the eye but readable by a browser or a platform. So when an image uploads, the system flags it, generated by Stylogen 2.
But that requires the developers to actually implement it.
And that is where the authors issue a fairly stinging critique of the computer science culture. They criticize the whole laissez-faire approach, the mindset of just releasing code because information wants to be free.
They're arguing for a kind of do no harm principle.
They are. They're encouraging the graphics and vision community to adopt ethical guidelines, similar to medicine or biotech. You have to ask, do the benefits of releasing this generator outweigh the risks of weaponization?
And if the answer is no,
then you don't release the source code. It's a call for gatekeeping in a field that, historically, hates gatekeepers.
it is. But given the speed of these advances, I mean, this paper is from 2022, which is ancient history in AI time.
It is, yeah. The authors argue we need these guardrails immediately.
All right, let's bring this home. For those of you tracking this for your research or bibliographies, let's do a rapid-fire recap of the key points.
Yeah, pen's ready. Source is Nightingale and Ferried, 2022, in PNAS. Methodology was 3 perceptual experiments over 700 participants using StyleGAN-2 faces.
Key finding 1.
Humans identify synthetic faces with only 48.2% accuracy. That's worse than chance.
Key finding 2.
Training and feedback provided no improvement over time, which suggests we've hit a saturation of visual realism.
And key finding 3.
Synthetic faces are perceived as statistically more trustworthy than real faces, a phenomenon they link to the averageness hypothesis of evolutionary psychology.
Perfect. That's the abstract. And I think the final thought to leave you with is simply this. We have spent our entire evolutionary history trusting our eyes. Seeing is believing.
And that heuristic is now a vulnerability. The technology isn't just mimicking reality, it's optimizing it. It's creating a version of the human face that is cleaner, more symmetrical, and more psychologically comforting than the messy reality we actually live in.
So the next time you see a friendly face online and you feel that little instinctive ping of trust,
You might want to remind yourself that your instincts were designed for the savannah, not for the internet.
thanks for listening to The Deep Dive. We'll see you next time.